Random variables independence. One remark to the previous slides. If probability of the event Xi belongs to AB is generated by some density Q of x, so this is just integral from A to B of Q of x dx, then expectation of f of Xi can be computed by using this formula, integral over R of Q of x multiplied by f of x dx. Xi is a random variable, so this is measurable function. I forgot to say that Xi is always measurable, so the pre-image belongs to the algebra of the subsets in the probabilistic space. And of course, if we have composition of two functions, Xi and f, this is again the random variable. So expectation of this new random variable, the composition of two random variables, can be computed by using this formula. Now, if we have two variables, Xi and eta, they are called independent if the probability of this event Xi belongs to A intersection with eta belongs to B. Intersections means that these events happens both simultaneously. Intersection of the sets. The probability of this intersection is just a product of two probabilities. Xi belongs to A and eta belongs to B for any measurable subsets A and B. If this identity is satisfied, then Xi and eta are called independent random variables. This condition can be extended to the case of 3, 4, and any finite number of random variables. And of course, here we need to take intersections of many sets. And this intersection should be again product of probabilities of such type of the elementary sets. Using this definition, it is not difficult to prove that expectation of the product of two independent random variables is the product of their expectations. Now, example. Suppose that we have random variable Xi, which takes only three values, -1, 1, and 2, with the same probability, 1 over 3. Now, we would like to model these random variables by another random variables independent on Xi, but continuous, not discrete. Continuous random variables which is uniformly distributed on the interval -1 C. And we would like to find C for which this eta will be the best approximation of Xi. What does it mean? This means that it is best in L2 norm. If we take the difference, take the power 2, the expectation of this difference should be minimal among all of the possible such type of random variables. Solution of this example. Variable eta is uniformly distributed over interval -1 C. This means that probability eta belongs to interval AB is just integral of the constant R over the interval AB intersected with -1 C. Of course, because it is located only in the interval -1 C, we need to take this intersection, where the constant R can be determined from this identity. The total probability, the full probability, is equal to 1. Using this formula, we obtain that the total probability is integral from -1 to C of the constant R dx. So this is just R multiplied by C plus 1. From this identity, it is easy to see that R is equal 1 divided by C plus 1. Okay, so we determine the measure that generates this random variable eta. Due to the linearity of expectation and independence of xi and eta, we have the following identity. Expectation of xi minus eta squared. We remember we should minimize this value. Is opening the brackets is expectation of xi squared minus 2 expectation of xi multiplied by expectation of eta. Because xi and eta are independent, the expectation of the product xi and eta is the product of expectation plus expectation of eta squared. Now we already know how to compute expectation of xi squared. Xi is random variable that takes only three values, minus 1, 1, and 2, with the same probability 1 over 3. So we need to take minus 1 squared multiplied by 1 over 3, 1 squared multiplied by 1 over 3, and 2 squared multiplied by 1 over 3. This is the same as we did here. Okay, in the same way, we can compute expectation of xi. Instead of squares, now we need to just simply take the values minus 1, 1, and 2, because we have no square here. And we need to multiply this by the expectation of eta. Eta is a continuous random variable, which is generated by some constant density. The probability is generated of eta is generated by some constant density r. So we can use this formula. Expectation f of xi is equal to integral of q of x f of x. Instead of q of x, we need to substitute the constant weight r. This r should be substituted in this formula. So that's why this expectation is just x multiplied by dx multiplied by r. R is 1 plus c power minus 1, so this is exactly this value. Expectation of eta squared, we need to substitute instead of x squared, because this is eta squared, and we use this formula. F in this case is power 2. So we have this formula. Computing this both integrals, this is easy to see that the first integral is just c minus 1 divided by 2. The second one is this one. We obtain this quadratic function. And the minimum of this quadratic function, this is just parabola, can be computed in the simple way. We just can take the derivative 2c minus 3 and equating this derivative to 0, we obtain the minimal value of this quadratic function. C is equal to 3 over 2. It is easy to see the minimum of this function is reached for c is equal to 3 over 2. So the best approximation of this discrete variable is the continuous uniformly distributed random variable independent on xi on the interval from minus 1 to 3 over 2, because the minimum is reached for this function. This is more or less practical example, because sometimes in some setup we cannot model discrete variables due to the physics, for example, but we can use continuously distributed random variables. And the question how to find the best approximation of our discrete random variable by continuous one. The questions to you: what is the best approximation of xi by independent eta uniformly distributed on the interval ab? The difference with this example is the following. Here we fixed the left boundary of the interval. A is equal to minus 1, and we would like to find only 1c. Here we don't fix the left boundary and right boundary, so we need to find both values, a and b. What is the minimum of this expectation? And this minimum gives us these two values. This is the questions to you.